Hello, everyone. Good morning, good afternoon, good evening. It is our great honor to welcome you all to the new format of Decentralized for this year, named Decentralized Learning Series. This year, Decentralized has been adapted to the global situation, taking the form of a series of virtual events. The common theme of those events is learning. And today, we are delighted to launch this series of events, having more than 1,000 registrants from over 100 countries. Today's event consists of two parts: opening remarks and discussion, followed by a workshop on the RippleX platform. I would like to invite the distinguished speakers of the first part. Our own CEO at the University of Nicosia, Mr. Antonis Polemitis, and Dr. Scott Stornetta, Chief Scientist at Eugen Partners. Adonis, Scott, the virtual floor is yours.
Thank you, Ilya. Can you hear me? Ilya and Scott, can you hear me okay?
I can hear you fine. Are you able to hear me?
Yes, I can hear you too. Well, first of all, I would like to welcome everyone who has joined. As Ilya said, we had over 1,000 pre-registrations. There's 274 people live as we speak now, and I think others will join and some will see it later. And I've been seeing the chat of everyone, some of them chatting only to the panelists and some to the panelists of the attendees. And it looks like we have people from all over the world. And this is very exciting. I am sad that we're not having Decentralized in person this year for the first time in 4 years, but it was unavoidable given the situation with COVID. But I am happy that at least we get to see some of our friends and our community here in these virtual events, of which this is the first one, and we will do them throughout the course of the year until hopefully next fall we're in a position to get everyone together again in person. So this series is kicking off to a great start. We have Dr. Scott Stornetta today, who is both a very distinguished figure in the field of blockchain and broadly a friend of the University of Nicosia and of Decentralized. And so I couldn't be more happy to start the series with him. I'll give a little bit of background for those who haven't seen Scott speak before or weren't at one of the prior series. Many people consider that Scott is one of the founding fathers of blockchain. He had written a paper with his co-author, Dr. Stuart Haber, at Bell Communication Research, and that paper constitutes nearly half the citations in the Bitcoin white paper, which is kind of amazing, right? Because that's where it's probably the most famous paper in this field, and half the citations in that paper come from Scott's work. Now, when he left Belcore, he was the assistant general manager of the Mathematics and Computer Science Laboratory, which had 125 people. And he's currently a partner and the chief scientist at Eugen Partners, which is a high technology venture capital firm. I'm going to tell you just briefly his academic history because it's absurd, with all due respect to Scott. He has a PhD from Stanford in physics. His dissertation was on the early thesis on neural networks. And before Stanford, he went to MIT, Harvard, and Brigham Young University. I'm not sure I know anyone who has been to Stanford, Harvard, and MIT. But now I do, and everyone else here does. I don't think he has left any elite university untouched. Scott, of course, continues to work in this field. He lectures widely on computer science, and his research is on not just computer science, but its impact on society, its impact on economics in particular in society. And one of the things that you'll see with Scott, it's important for him that these technologies have real world applications, right? It's not just theoretical. So the format of how we're going to structure this hour is the following. Dr. Sornetta will give us some opening remarks. He will touch upon a couple of topics he thinks are important right now in the blockchain field. After he's concluded that, I might ask him some questions, but I'm also going to keep an eye on the chat and the Q&A for your questions. So if we have some great questions coming from the audience, we will work those in because the audience participation would be amazing. So listen carefully to Scott's remarks, and if you have questions, we'd love to filter them in. And then Elias, your job is to tell us when we're out of time, because I have a sense otherwise we'll just go on forever. So Elias gets to pull the plug on the show when the time comes. So with that, I will turn the floor over to Scott.
Well, I appreciate that. Again, you listed some universities that I've been associated with, and I'm happy to add the University of Nicosia to that list because we're focused on the future, and your universities rise. And, universities don't rise just because of the whims of economic forces. They rise because of leadership. And I'm going to touch on that in my remarks in a minute to tie them into the blockchain. But I just want to express my appreciation for the staff that work with your leader, Antonis Palamides, and the great support that he's provided for the whole decentralized thesis and the leadership that he's provided. And again, those aren't empty words for me, because as I was thinking about what I might say as an opening remark or two, I think I could capture it all with a phrase: what a difference a year makes. And I mean that in both a kind of the good news and the bad news story. So a year ago this time, I was in lovely Athens, a beneficiary of having been invited to speak at last year's conference. The weather was wonderful, and there was not a mask in sight. And yet things were, in a sense, a little bit gloomy about the blockchain and decentralized space. There was a lot of second guessing and asking why things weren't progressing as fast as they had been expected to, and what could be done to increase the impact that decentralized thinking in general and the blockchain in particular could have. Now, fast forward a year later, instead of being within a view of the Acropolis, I'm here in sort of a large storage closet at a place where I was just giving a lecture, and I needed a private room, so they just put me off here. The sky is cloudy, it's overcast and raining. But when you turn to and of course there's a global pandemic going on. And yet when you turn to the blockchain space, what a difference a year makes again. It could not be sunnier. So much of the concerns that were expressed about why is blockchain not seeing the traction that many of us had hoped for were very palpable at last year's conference. We knew that there was promise, and we'd placed our bets, so to speak. But again, and this comes back to the leadership that I see evidenced with the University of Nicosia. There was a commitment for the long haul to see this field begin to flourish. And there's really been a crescendo of events in the last few months that I think help to punctuate why it is that it's a very sunny day in the decentralized peer-to-peer blockchain world. Let me just cite a couple of them. I'm not going to talk much about stable coins and things in that space only because Ripple is, I'm the opening act for Ripple, and I'm not going to steal their thunder. But let me mention a couple of other things that make these very exciting times. One, the announcement by PayPal, which I consider a truly watershed event that is going to help to legitimize the concept of cryptocurrencies, including Bitcoin. And again, I've made it clear that I have a kind of neutral position on the various cryptocurrencies because I think there's plenty of need for innovation and improvement, but am very strong long-term about their potential for really bringing about a more, and this is long-term, mind you, a more egalitarian world, one that is multipolar balance. And multipolar balance really is key to the decentralization notion. It leads to more peer-to-peer interaction, less hierarchical interaction, and that's just a good thing overall. The second thing I would cite, and I'm just going to caution that many people would consider this just the opposite of good news in the blockchain space, and that is the rise of the government of China's decision to move forward in a major way with CBDC, a central bank digital currency. I say many would consider that a negative because this was not the decentralized, non-hierarchical promise of blockchain that we were initially hoping for. But I think there's a huge silver lining to that, and I hope we have a chance to talk about that later on. And then the third thing I'm going to cite, just to keep the list short, is in that same sort of realm of good news, bad news story. We here in the United States have just gone through a pretty tumultuous election. And without taking a partisan stance on the various candidates and the issues, I note that I consider it of singular importance that the Associated Press thought it was important enough that they enter in onto the blockchain the data surrounding their calling of the election and the votes of the Electoral College. For me, it's in a sense sad that the Associated Press felt the need to have to register this so that truth would be established. But isn't it great that the mainstream media is grasping why it is that the blockchain can be such a firm foundation for a better world? Anyway, there's a lot more that I could say, but I wanted this to be an opening statement rather than a lecture, so I'm going to stop there.
Thank you, Scott. Let's build on the items that you mentioned, okay? Because there are at any point in time multiple political philosophies floating around in the blockchain space that overlap with the technical aspects, right? And I'll try and give you my categorization of them and see how it maps to what your remarks are. There are the, let's say, public decentralized cryptocurrencies that have effectively more or less no point of central control and depends on the current cryptocurrency and so on. And those tend to go with a political philosophy that says their greatest political benefit is that they're free of state control and they're more peer-to-peer and so on, right? Let's call that bucket one. Bucket two, which is one of the examples that you mentioned, is actually, centralized providers who deal in cryptocurrencies, right? So PayPal, as you mentioned, PayPal in many ways was one of the bad guys for the community 5 years ago, right? And for folks who are involved with the cryptocurrency community, there's always this interesting trade-off because you want adoption, you want people to use them. But to date, most of the adoption has come from kind of centralized on-ramps, off-ramps. You know, Coinbase probably being the largest in the United States, and now PayPal, which is much bigger company in general than Coinbase and much broader reach. You have this interesting question of people are going to say, well, okay, on the one hand, it's good, more people will be exposed to Bitcoin, or, right? But are they going to be exposed to it in a highly centralized context? And is that good, bad, or indifferent, right? So kind of that's the one bucket. Then there's the other bucket of blockchains that are not necessarily fully permissionless. And those could be corporate. It could be a consortium of banks that are using blockchain to settle trades among themselves, but you or I can't join them. You have to be a bank, right? And then the big emerging question of the central bank digital currencies, which is what you had mentioned and where China has, I think, made the most progress. Certainly it's the large economies, it's the one that's made the most progress. And there are folks who would say, wow, like this is, in fact, the opposite of those initial values, that this might be a way to assert more state control, right? Like of a CBDC, depending on how it's designed, because you can take different design considerations, but my guess is people would say, oh, a digital one is likely to have more controls on it or than cash does today, right? And so it's an instrument of state control. You have also the flip side, right? That you have some legislators or some countries who are against the decentralized currencies and would prefer that things came onto a more. So this is kind of the spectrum of activity, right? And there appears to be activity happening across the spectrum, actually, right? Well, even on the decentralized side, you have now decentralized finance, where those are more or less decentralized, and on the other end of the spectrum. So my question is, from your perspective, because this is ultimately personal, there's no right answer to this, right? As we develop over the next 5 years, what happens at this intersection of political philosophy and technology? Does it continue in kind of opposition, some parts in opposition to the other? Does it consolidate in one direction? Does it become irrelevant? How do you think about this question?
Well, again, it's a you've fallen into my carefully designed trap of asking a question that I could talk about for hours, because I really think a lot about the intersection between technology and the impact and effect it has on society. And, you know, how is it that we're going to use this to build a better world? And let me respond in a couple of ways to some of the particular points you've made, maybe as a way of elucidating more my general philosophy. One is, you talk about how in an initial vision, we were all going to be peers. We were going to disintermediate the evil concentrations of power and capital. And having eliminated them, there would obviously spontaneously arise world peace, because once you get rid of the bad guys, what's left but world peace? And so there's this feeling of concern that the technologies that we invented with such promise have been co-opted by the bad guys. And I think that's, while it's certainly an understandable position to take, I think the truth, quite frankly, is both more subtle and also more positive. And that is, these folks that have embraced these traditional players, whether governments or large corporate players that have embraced the technology are essentially allowing in the very subversive peer-to-peer influence that they might otherwise think that they have some control over. And so I think of it as blockchain infiltration rather than blockchain being made subservient to. The technology will play its way out, and it has an influence and a power of its own to begin to affect those organizations. And those organizations that currently find themselves, sort of big man on campus, sort of in pole position, are really leading the way to show others how they can become part of a multipolar world. And so even though that wasn't their intention, their embrace of the technology is inevitably going to lead to additional parties that realize that they can play, in essence, the same game, and thus help to equilibrate, create a broader balance of power. Now, some of you may be thinking, well, that's going to take a long time, but it's important to understand who it is that's saying this, and this may be a condemnation of me, but that is, my training was as a physicist, and physicists are always thinking about what happens in the asymptotic state. Eventually, how will everything shake out? And so I'm extremely bullish about the move towards more decentralized, peer-to-peer, multipolar world. And I think blockchain is a big part of moving in that direction. Now, I also want to take on a second point, and this will be my final, it's just 2 points. And that is, you talked about effectively the permissioned versus the permissionless, okay? And in a sense, I think that is a reasonable division, but one that masks something even more fundamental about the divide. And it really goes to the concept of self-sovereign identity. The comment that I'd make is our concerns about permissioned versus permissionless. I think when you drill deeper down, are concerns about us not having personal control over our own identities. And so from my perspective, and I'll put this out, and others I'm happy to have disagree with me, I'm happy to hear, contrarian viewpoints. From my perspective, I'm fine if everything ends up being a permission system, so long as it's integrated with self-sovereign identity and my permissions are my own. I don't think permission versus permissionless is the divide. It's the individual having sovereignty over their activities. And so I think as we broaden the permissioned world, vis-a-vis, and I know I keep harping on this, vis-a-vis self-sovereign identity, it essentially achieves the goals that we initially attributed to the permissionless world. But I'm sure there's plenty of intelligent people that would like to disagree with that, and
I would like a clarification, because I'm not sure if I agree or disagree, but I definitely want a clarification. So my understanding of self-sovereign identity is I can come and say I'm Antonis because I can prove in some decentralized manner that I'm Antonis. I'm not bringing my driver's license, right? I'm not bringing my passport. We agree that that's at a simplistic understanding is, and let's say we agree I'm the basis for, or there's some decentralized system for that. That's the basis for who I am. But I'm in a permission system. And in a permission system, let's say transaction system, someone says, I have a problem with Antonis. The regime has a problem with Antonis. We know he's Antonis because we can use the self-sovereign system that he's using. we've all agreed that it's Antonis. But you know, he's a bad boy. He has not voted for the emperor this year. We're going to cut off his payments. How does the self-sovereign identity help me in that case?
Right. It's a great question. And again, I'm more than willing to grant that there's a lot of legitimate arguments that come up on the other side. But I would assert that what is being talked about in those situations is using anonymity as a kind of blunt instrument for asserting individual rights. And while in some cases it may be the only recourse, I think there is a longer term argument to be made that the control of one's data rather than anonymity, okay, allows us to construct systems that gradually will overwhelm those attempts to provide selective access in a punitive way. And so I understand that anonymity is a recourse, but in a sense, it's the bluntest of instruments, okay, in finding recourse. And rather than talk about this as a privacy anonymity kind of debate, to me, it's all about control and ownership of one's own data and one's own identity. I think that ends up triumphing. But again, as they say, as those that critique physicists who say, you know, don't worry because asymptotically this is all going to work out fine, there is the counter anecdote, and I can't remember who it was attributed to, who says, yes, but asymptotically we're all dead.
Right, exactly. Even economists say it, right? In the long run, we're all dead in the long run. Okay, let me pick up on this because there's a word you used multiple times that I don't hear often in this space. And I would like you to elaborate on what you mean. And it's the word multipolar, right? And you're saying this will lead to a more multipolar world. And I actually don't hear that discussed a lot. And you mentioned it multiple times. And I think it's core to your thinking and how you imagine a good outcome from all directions, both the centralized and the decentralized and the partially centralized moving. Tell us what multipolar means 10 years from now. How does it tie together?
Great. I know I have used that word multipolar. Obviously, it arises in the context of geopolitical affairs where we talk about a unipolar world, a bipolar world, and then a move to a multipolar world. But perhaps a better phrase that I should have used, rather than drawing on the nation state world for my example, is peer-to-peer. Because to me, multipolar just is a big guy's word for the little guy's peer-to-peer. You know, obviously I can't answer definitively for theories of history, but I know that, for example, there are many historians, particularly historians of technology and economics, who cite the multipolar world of Europe in the 17th and 18th centuries, namely not one dominant entity, but the fact that power was roughly divided amongst multiple parties as being the absolute foundation for what created such an outpouring of economic growth and technological innovation. And it's that sort of peer-to-peer effect that I think creates so much value and so much respect for the individual that I just see it as a net positive, a net good. And so anything we can do to move towards a less people on top and people on the bottom world, and rather one that is more peer-to-peer, with mutual respect, I just think that that helps us win on so many fronts. And so for me, multipolar and peer-to-peer are really trying to say the same sort of thing. And now I have to apologize, but I'll keep it short and note that in passing, my own recent research and projects go very much to ways that we can apply the peer-to-peer, the value creation of peer-to-peer in improving societies. And I'm not going to talk about that today. I got to give a plug a month ago for 3 of the projects that I'm working on that enable that peer-to-peering. And I spoke at some length about one of them. But that's what I mean by multipolar.
Got it. It's like a fractal form of decentralization. And
Yeah.
there's a lot of discussion about that, including in kind of non-blockchain versions. You see it, like Balaji Srinivasan speaks about this a lot. And you hear, can you form a city? Will you see effectively city states? Kind of right, because it's fractal. Decentralization is not either you're a unitary one state to rule them all, or it's every single individual working by themselves. It happens at different levels. And so broadly, by the way, I agree with that. I think the technology, it's a little bit like the medium is the message. The technology allows you to do things more decentralized than you did before. And that's why the whole thing is called decentralized. Right? We're in the decentralized learning series. And we saw it in media with the internet. And I think you'll see it in broader context now with this value transfer. Okay, I have one more question along these lines, and then I'm seeing some interesting things pop up from the audience that we can go address. But it's a question I like to ask many people, which is the following. Everyone often in the community says, oh, I wish X did something different. Oh, I don't like this policy, Y. Oh, I'm so upset at the legislators, or why is my country not moving fast enough? Let's say we made you head of state for the day of a generic Western country. It could be France, it could be Canada, it's the UK, it's the US, it's Germany, just have some context. So you have a fully developed financial system and so forth, a Western style economy. What would be and you can pick your number, it could be 1 or 2 or 3, most important changes you would make to help accelerate the development? I mean, if you were king for the day, what would you do to help society move towards this better outcome faster as it relates to these technologies?
Wow. Must say that the lure of the ring is strong. But I do note in passing, before I give my real answer, that if such a thing were to come to pass, my wife would immediately apply for dual citizenship in some other country as well. So let that be my, the thing that keeps me in check. Let me just say a word about what it means to be poor. And I apologize for starting out in such a philosophical way, but I will try to get to something quite concrete. In my mind, to be poor means that almost no matter what you do not have access to the real collective riches that the surrounding society enjoys. And so, a key to eliminating poverty is not to have equal outcomes, but to greatly improve the equality of opportunity. And I think this can happen in some very natural ways. And I'd like to talk about the relationship between the open source software movement and the benefits that blockchain confers. And then I'll close with my policy action, having offered that perspective. Part of the great benefit of the open source software movement is that suddenly work that heretofore could only be done inside the largest, best funded corporations, the ability to innovate was now opened to a much larger class of people, because there was a common pool of goods that everyone suddenly had access to that heretofore had been so expensive it was prohibitive for people that wanted to innovate on top of that to get into the game. And I think the decentralized and blockchain efforts haven't fully grasped how similar they are to the benefits that the open source software movement brings. Okay. And what's changing is that instead of the software being open source and available from a GitHub repository, is that we're making a shared data set, a shared amongst an ecosystem set of data is now becomes part of that bountiful commons and allows a much larger group of people to gain access to that and innovate on top of it. And so finally, coming back to the king for the day, to me, the general thrust of my policies would be to create more of those common goods that don't provide, a fish for a day, but give everyone access to fishing rods so that they can, learn to fish for themselves. And that would be the thrust of things. Obviously, it would have implications for the banking industry, financial services, a whole host of very specific areas, but it would be trying to pool those common goods and make them more accessible for those that had heretofore been shut out, so that they can create collective wealth for the society. And I think with the ability to create wealth, with the economic power, naturally follows the improvement in human rights, and I think a whole host of good things follow.
So I think that's a great answer. Okay, I'm going to shift gears a little bit. We have some questions. Some of them are a little bit more tangible and practical, and we might change the tone a little bit. So we've done a lot of high philosophy so far. I like this question a lot. At a recent 2020 WYO Hackathon Wyoming Blockchain Stampede, Scott Sternetta did a really interesting mentoring session for entrepreneurs. Why many startups fail, boiling down to product market fit and decisions. And maybe a few words about this would be fine for our community here. And what I'd like to note is we do have, I think, a very entrepreneurially active community. I think this space tends to attract folks with an entrepreneurial bent. And so I am sure at any point in time, within the 323 people watching this or the hundreds more who will watch it later, there will absolutely be folks who have started a business or working on a business or thinking of starting a business. You're in the business of funding entrepreneurs who start businesses. So what would you say to someone generically in the space who's working on a business? What are the important things they should keep in mind, and the key success factors?
I'm happy to diverge off of there, if that's okay.
Yeah.
I actually do give this talk to groups that I've been able to meet individually with the CEOs and management teams, and then I tailor my response to that community that I've met with. But I have a kind of opening slide where it references something else, and it lists the 10 reasons, 10 reasons why most startups fail. And I say, I think this is actually a little like those t-shirts that say there are 10 types of people in the world, those who understand binary and those who don't. And it really comes down to just 2 reasons. Okay. There are 2 reasons why most startups fail. And again, I'm happy to provide a link to a longer, an hour that I spend talking about this. But the first reason is that for those of us that come from strong technology backgrounds, we have to almost overcome our innate tendencies to be technology focused and thinking how smart we are, and the need to pivot to be customer focused and thinking how we can build something that will actually solve a problem. That's reason number one of the two. Reason number two comes down to a story that I like to tell. I think it's funny, but your mileage may vary. Anyway, there's this highly successful CEO, but he's very well known as someone that speaks very succinctly. And so someone's interviewing him and he asked him three questions. First question, what makes a great CEO? And he says, great decisions. And he says, how do you make great decisions? He says, experience. And then this third and final question is, and how do you get experience? And he says, bad decisions. Okay, you could obviously hear it where it was going. And this is really the second reason that most startups fail. People do not have enough experience. They make bad decisions. And the silver lining there is twofold. One, if you persist long enough, okay, you will eventually make enough bad decisions that you will gain experience. And it will be that experience that will lead you to making good decisions. The alternative is to find a friendly father figure or a nice, kindly, experienced aunt or uncle that can kind of mentor you along so that you can accelerate the process. But yeah, you need to make a product. You need to turn technology into a product that actually solves someone else's needs, not yours. And you need to survive long enough that you make enough bad decisions that you gain experience and can start making good decisions.
Great. Let me take another question from the audience, which I believe, in a way, somewhat abstract, goes back to your common goods point, because we do have a variety of common goods as humanity, but here it references environmental common goods. And the way this question is structured, it says, how can blockchain help in environmental sustainability? And the person asking the question says, our region, which is the northern part of Nigeria, is affected by environmental issues like deforestation and other climate change issues. And this has always been an interesting topic to me because it has come up many times through the years with blockchains. And maybe there is some type of solution for the tragedy of the commons that has to do with this, that can be touched upon with blockchain, but I don't think much has happened yet. And I'm curious about your thoughts of, is there some type of linkage here? What could it be? And maybe how we could get people working on these topics.
Sure. Well, I guess the first thing I would say is that I am not Jeffrey Sachs, okay? And what I mean by that is, again, I had respect for the man, but he's the kind of person that wants to be king for a year, I think, and has the idea that if people would just do X, bang, the problem would be solved. And there's a kind of mega scale activity about, wiping out deforestation issues or climate change, on a grand scale. I am what I would call a small ball player. And so I think that the problems that you're citing in Nigeria are very large. And it's obviously not just Nigeria. We could talk about sub-Saharan Africa. We could talk about parts of Southeast Asia. We could talk about areas in Latin America. And the problems are very real and very persistent. And so in my small ball way, I don't aim to conquer them all with a single stroke. But what I do say is that transparency goes a long way to leveling the playing field. Transparency in the supply chain is a very specific area of applicability, particularly in the agricultural space, where we are quite focused and active as a venture capital firm, because we think it can be a great equalizer to helping a larger group of people realizing the implications of their choices and therefore making better choices that in a kind of bottom up way, I think can begin to have an effect on some of these enormous challenges that that are going to take some time to work through.
Okay. I think that's a fair answer, I think. All right, I'm going to another audience question, which is, and well, it's a tough question. I don't know that the question says, well, thanks you for joining, and that's wonderful. And then the question says, what your view is about will there be, and what a digital euro might look like in the near future. Do you think that's in the cards, first of all, right? We know what's happening in China. And let me broaden the question, right? Can we imagine a CBDC in the US and Europe? I mean, the major currency pair in the world remains the US dollar and the euro. How do you see the state of play there now? What do you think the evolution is going to be? And I'll add my question. Do you think there will be design decisions that are different than the decisions made in China?
All right, let me take the last part and work backwards. Yes, I definitely think there'll be design decisions that will be different. Okay. I think we're going to see move to CBDCs in Europe more quickly than the United States. And as a United States citizen, I regret that. But I think, again, it doesn't have to be a bad thing that these currencies are innovating. Okay. For one, if they fail to innovate, those that can innovate are going to push them to the side. And maybe that's not in 5 years, but I certainly see it in 20 years. Okay. The second thing that I think is interesting, because I've seen a couple of comments come up about the banks and wishing we could, the banks as bad guys and wishing we could get rid of the banks. One of the most ironic things to me about CBDCs is that the banks, who have long counted on the central banks as being their eternal allies, could in fact suddenly become their most active competitors. And while these banks have been sort of worrying about the barbarians at the gates with Bitcoin, it could be that their most trusted ally ends up being their biggest competition. And I think there's a kind of, and I don't mean this in a mean-spirited way, but I think there's a kind of delicious irony there with the growth of CBDCs. The other thing, though, that I want to say, and this is something that I feel very strongly about, is that there are plenty of ways to redefine money so that it's not just a question as to whether it's a currency controlled by a central bank or a currency controlled by something else. There's ways to innovate what a currency is and the use of money in the system. One of my favorite small ball situations is something called Sardex, which is something that coexists with the euro in Sardinia, and where they have tweaked the concept of a complementary currency so that it enables more local community growth and redefines the merchants and the customers as essentially taking on some of the roles that banks have heretofore had an almost exclusive monopoly. Now, that's just a teaser, no time to elaborate on it. But what's inspirational about it is, rather than simply try to create their own currency, just like the other currency, but under their control and not someone else's, they've asked themselves, what could currencies become? When we were at Belcore, we often used, in trying to think of how to sort of invent the future, and this is as good a comment for me to close on as any, is that you don't try to make a digital version of the existing whatever. Instead, you ask, what does the existing thing dream it could be? What does it wish it could be? You know, a kind of money plus plus, if you will, for those of you that have a technical background. And that's what the promise of this move towards CBDCs and other stable currencies is. What does money wish it could be? You know, what is it that we will look back on and say, before we finally discovered what money really could be, we had proto money that everyone used. And it seems like just such a crude version of what we have now. And that's the way you have to turn things upside down to innovate. What does money wish it could be?
Look, I think that is a great closing comment. I think it's very, very true. I think we see it in all technology transitions that the first version of the new thing is the old thing done as the new thing. So some of the first TV shows were basically radio shows with a camera in front of them. A lot of the early internet work was, it's a newspaper, but on the web. It's a magazine, but on the web. And in some ways, part of what needs to happen isn't even necessarily a technical piece, it's a shift in perception. And for me, one of my favorite examples on this is Airbnb, where, yes, it requires some technology, like it's a website basically, and sure, a mobile application, but it's not like highly advanced technology. What it requires is a shift to say that if you invite a bunch of strangers to sleep in your house, not everyone's going to get murdered and die, right? Which is kind of what anyone above a certain age, and unfortunately I'm above that age, when I first heard of B&B, I was like, okay, we're all going to die, right? I mean, this can't possibly work. And it wasn't that there was anything in the technology stack that allowed Airbnb to happen and couldn't have happened 5 years earlier. It was that no one could see the social aspect differently. And it's one of the advice, and I'll close with this, I always give to the community. I am extremely bullish on the younger people in the community, not because of any technical reason, because I grew up in a world of centralized ledgers. Just like I couldn't see Airbnb until it was obvious that Airbnb happened. I certainly wouldn't have thought of Airbnb. There must be thousands of untapped design spaces that we, the people in positions of authority, don't see. They're there, they're waiting to be uncovered. They will not be, it is wire transfers, but on a blockchain. We should do those things too, right? It's useful that the New York Times is on the internet, right? Like those things will also happen. They'll also migrate to a blockchain. But the interesting things are the ones that we couldn't do before. And it's hard because you don't see them. You don't, until Airbnb exists, you don't imagine that Airbnb could exist. And so, and I believe the bigger opportunities, or the biggest opportunities for people who are starting in the space now, is to look for the things, what money could be, or what business designs, what social designs, what social constructs don't exist now and we can build. And so with that, I would like to first thank Scott for his hugely insightful remarks and for taking the time to be with us. I would like to thank the, as of right now, 337 participants who have been listening and having a discussion in the chat and adding questions. And of course, the IFF team and Elias and various members of the team and Elena that helped with the organization. I believe now we hand it over to the Ripple session, if I'm not mistaken. So, Elia, retail
Yes,
control.
Adonis, Scott Adonis, thank you very much for this insightful discussion. And as you mentioned, right now we are ready to proceed to the second part of the event. And at this point, I would like to pass the virtual floor to Michael Zochowski, Warren Paul Anderson, and Tyler Storm from Ripple, who will deliver the RippleX workshop. Michael, Warren, Tyler, the floor is yours.
All right. Thank you very much. Can you guys hear me, everyone? Looks like audio is good. Excited to be here today. Appreciate, our hosts. We're big supporters of the university through our the University Blockchain Research Initiative. We've been, working with them for a couple of years now to help develop, curriculum, and we think that they're really been a leader in the global press for education around blockchain technology. So I wanted to just go over a presentation today. My name is Warren. I've been at Ripple a little over 4 years. I've been in the blockchain space for about 7 or 8 years. I've worked on the Bitcoin protocol, building applications on top of that, and joined Ripple in 2016 to do something similar. So we've got about 2 hours today. So we're gonna take a break after an hour to give everyone time to do what they need to do so that they don't miss any information. But for now, I'm gonna switch to our presentation and hope everyone can see my screen. Okay, so we're gonna be discussing how to build trust, utility, and liquidity with blockchain technology. So just want to go over kind of a quick agenda. We'll go over a brief history of Ripple. Ripple's been around for about 8 years, and there's a lot of information about like what Ripple does that I want to kind of clear up and make sure that everyone knows for context. We want to introduce what RippleX is and some of the technologies that we're working on. I'll hand it over to Michael, who will discuss Pay Id, which is a new protocol that he was instrumental in building. We'll take a 5-minute break. We're going to talk about issued currencies with a demo. So Tyler Storm's going to be leading that. Issued currencies are an exciting feature of the Xrp Ledger. We're going to be talking about smart transactors on the Xrp Ledger, and then finally some tools and services that anyone can use, for free without permission to continue to build some of this utility, trust, and liquidity. So with that, so a quick kind of history of basically Ripple. So Ripple is an interesting, it's both a company and it also builds out open source technology. So we build out proprietary technology primarily for financial institutions and what we call non-bank financial institutions, which are payment companies. Ripple the Ripple Consensus Ledger was created in 2012. We now call that the Xrp Ledger, followed by a series of different technologies that are all open source. Codius is a kind of Ripple's version of a smart contract platform that's agnostic to any blockchain. Interledger, which I'll go into a bit, which is an open payment protocol for clearing payments. The Xrp Ledger, which was rebranded in 2018. We launched Spring, which is a developer platform that builds on top of these open source technologies in 2018. We recently launched something called Pay Id, which is an addressing layer for people to be able to send and receive payments. It looks very similar to an email address for payments. And then we recently actually rebranded Spring to RippleX to kind of create more clarity as to what how Ripple's involved with the initiative. We've been building out proprietary software, since pretty much day one, primarily directed, like I said, toward financial institutions. And we have a host of products that we kind of couple now into the RippleNet Enterprise Payment Network. I was at some point in 2017, we created the on-demand liquidity product, which we previously called Xrp, which actually uses XRP to do the cross-border payments. And we've seen a huge amount of traction with that product, so we're very proud of it. So what is RippleX? So Ripple is really kind of divided into two different houses. You have the RippleNet enterprise blockchain, which is, has 500 plus financial institutions using it. This is your classic enterprise software, proprietary. There's, a sales pipeline, customers sign agreements, they use the platform. And then you have RippleX side, which is the open developer platform for money. We offer, open source tools, services across Xrp, Interledger protocol or ILP, and Pay Id. So those are really kind of the two business units within Ripple. We often use the example of similar to Amazon, where Amazon, covers lots of different products in their marketplace. RippleNet, started with cross-border payments. We recently introduced something called line of credit, which is more of a lending product. And then RippleX is more like, you could, using the same analogy, almost like an AWS, where Amazon built out early infrastructure that they wanted to use themselves, and they eventually offered that infrastructure up for developers to use. So that's really what RippleX is. We're building this open source technology. RippleNet, consumes a lot of that open source technology, and now we're, making sure that it's a great platform for developers to build their own RippleNets or, their own payment applications to take advantage of the blockchain. So just kind of an overview of RippleX. So we offer programs through content just like this, hosting events, attending events. We offer support. This is classically, technical support, where we make sure that developers are, unblocked and they can solve the problems that they need to. We have deployed capital across a number of different companies. From 2018 to present, we've deployed about $500 million worth of capital. We are constantly looking to offer grants to projects that we feel that have some track record to actually build applications at scale. We also contribute to open source protocols, including the Xrp Ledger, Interledger, and Pay Id. In fact, the RippleX team, there's approximately 45 to 50 engineers, and every single one of those engineers works on open source technology full time. So it's really a treat for the engineers to be able to wake up every morning and contribute to open source technology that's really, transforming the world of payments and finance. We offer tools for developers to be successful. We'll cover those a little bit more in depth, but basically it's a reference wallet, an SDK, an API that's more of like your classic REST API, different libraries that can access the Xrp Ledger, because building a blockchain is actually pretty complicated. It's a complex protocol, so we want to make sure there's enough abstraction layers on top of that protocol to make sure that developers, any developer, not just a crypto blockchain developer, but web developers, mobile developers, they have the tools that they recognize and that they can use to build killer applications. We also offer services. So we host a few, what's known in the industry as test networks or test nets. These are networks that mirror the main network, the production network, in various capacities. The DevNet is kind of like it hosts all the latest beta of the Xrp Ledger. So if you're interested in testing out some of the new features and functionality that will be potentially deployed onto the main network, then the DevNet is a great way to do that. Testnet, which is really just a mirror of the main network for developers to be able to test their applications before they upgrade to the latest version. We host the ILP test network, which is very similar, where it's basically running the latest version of Interledger protocol. And we also host an Explorer. Explorers are kind of like the search engines for blockchain, where you can look up transaction history, you can look up different ledgers in a ledger in the Xrp Ledger is very similar to a block in Bitcoin. So having that exposure and being able to look up is great for developers to verify that they're building the right things. And then also a data API where you can query the ledger directly through this hosted API. So in case you're not an interface person, you have that data API. So you can kind of think of RippleX as this open payment stack. And we think this is exciting because there really hasn't been a truly open payment stack that's been built. And when I talk about an open payment stack, I'm talking from the network, the settlement network, all the way up. So we classically view Xrp Ledger as a settlement network, where the actual transfer of funds is happening in this decentralized blockchain. We see Interledger as a layer above the Xrp Ledger. Interledger can support any blockchain or currency, whether it's a cryptocurrency or a fiat currency. Interledger can kind of support that in more of the clearing and messaging side. So classically Swift is a major provider of clearing technology, where they're actually sending the message across for banks to be able to settle funds. Interledger does that in a similar way. I'll get into the details of how that's kind of different and how Interledger has been built. Pay Id is a new protocol that we developed. Michael's going to be talking about that later, but it's kind of split into two. There's the classic addressing for just your peer-to-peer. It's literally just user $domain.com. And then we have something called Pay Id Plus that's really geared for payment setup. So this is user authentication, compliance, receipts, invoices, subscriptions. These are all the other stuff that people need to actually process payments. And Pay Id comes with that supported. So moving kind of to the open protocols, I'm going to touch a little bit on each one, focusing more on the Xrp Ledger, particularly around consensus, because it's such an important topic. So, as I said, Xrp Ledger, Ripple contributes to these open protocols. There's lots of third-party developers that are constantly contributing. We see that network grow. Since I joined Ripple in 2016, I've seen a huge amount of developers continuing to build on some of these protocols. It's the nature of open source technology. We think that they're great. They become very hardened over time because more developers have access to proposing changes. As I said, Xrp Ledger we think of as payment settlement, as this decentralized cryptographic ledger. Interledger being an interoperability protocol for payment clearing. So it's very important that a lot of these different payment networks in the world, including blockchains, are actually not interoperable. So if I have Bitcoin and I want to send someone Bitcoin, but they want to receive an Ethereum or an XRP, how do they do that? So being able to do that actual, what classically called an FX transaction, but in a completely open protocol, that's really what Interledger does. And so we think it's really important part of the puzzle for building out blockchain technology. And then finally, Pay Id, having being able to manage these crypto addresses and bank addresses. I don't want to steal Michael's thunder, but we think that accounts, where account numbers are really kind of like IP addresses from back in the day. You can imagine browsing, the web, the internet right now, and having to type in IP address every time. It just wouldn't work. People type in human readable addresses and it works really well. So we think the PID could help solve that. So finally, just kind of getting into the Xrp Ledger. So the Xrp Ledger, we talk about this universal way to settle payments. It's open, decentralized. It's based on a distributed agreement protocol that is very similar to what we call practical Byzantine fault tolerant. And this is kind of what drives consensus or agreement in the network into which transactions are valid. That uses XRP as a native asset to reduce transaction spam. That was really the first kind of use case for XRP. In an open network, you're susceptible to having people spam the network with lots of transactions. So you have to have a native asset there that has some value that can actually reduce the amount of transactions. So every transaction on the XRP ledger, there's a fee imposed. That fee is burned. The fee itself is quite low. The base fee right now is 10 drops, which is essentially one XRP is 1 million drops. So you can see it's like fractions of a penny. And that fee can actually escalate with the network load. So there's a lot of really smart algorithms that go into ensuring the XRP is almost like a self-healing. We kind of think of it as a living, breathing organism that, when it's under attack, it kind of it fends off attack by triggering certain elements. XRP supports end-issued currencies. Tyler's going to go into a little bit more of what that is later on, but we're pretty excited about that feature. It was an early feature in the Xrp Ledger, and we've seen it play out in other networks. You can actually see it live if you go to livenet.xrpl.org. It's a great visualization of how the Xrp Ledger works. You'll see, actual ledgers coming in real time. You'll see a whole host of data. You can click through it and see the data formats, but it's a great tool. So the Xrp Ledger was designed, Arthur Brito, David Schwartz, Jed McCaleb, really around this simple design challenge. In an open network with some possibly malicious participants, reach consensus on replicated ledger state in response to client transactions. So, this problem set was actually kind of worked on. The creators of XRP Ledger actually had worked on Bitcoin for several years before creating the XRP Ledger. So they saw some of the design constraints in Bitcoin and wanted to create, an alternative to Bitcoin, kind of using this format. So some of the guiding principles they used were around correctness. So, the XRP Ledger values correctness over everything. And that's ensuring the protocol rules to ensure this ledger integrity. You can think of, you definitely don't want malformed transactions to be approved in the Xrp Ledger, because that could potentially compromise a lot of senders and receivers, which are expecting to send and receive the value that they send or receive. So second to that, agreement. Agreement is a critical part of the Xrp Ledger, but is valued second to correctness. The notion in Xrp Ledger is that if the nodes can't agree, or if they fail to agree, then they agree to defer. And what that means is if ledgers can't actually, or if the nodes in the network can't agree on a set of transactions to approve, what they do is they just go into another round of consensus until they come to that agreement. And then finally, forward progress. If the quorum of these nodes cannot be reached, then forward progress stops. So the Xrp Ledger was designed that if there's something wrong, then the network should stop. And then what that allows for is the node operators to come together and figure out what's going on, restart their servers, and basically come to agreement again on what the next proposed transaction set is. So, this is actually a security, a big part of the security of the protocol, because we don't want transactions that have been malformed to persist on the ledger. So some of the critical components of the Xrp Ledger consensus start first with deliberation. And this is basically when peers or nodes on the network are basically discussing in their chatter with on what transaction set should be approved. Once they kind of come to a general agreement, they fully validate the transaction set, and this is only if a certain amount of quorum is reached. And then, of course, the preferred branch, which is basically the set of transactions, with the most network support, that's going to be the transaction set that's approved. You see similar kind of components to this in Bitcoin and other blockchain networks. So just some kind of highlights here. Validators agree on this transaction set. They apply it to a given ledger. Validators sign each ledger they build. So there's actually, this is like analogous to like if you have a room full of people, they're trying to agree on something. You want to make sure that there's high value placed on that agreement. But what they should be agreeing on is correct. So the correctness, again, is the critical component. You'll notice that not 100% of the nodes need to agree, and this is actually a design consideration that was taken in. But a substantial amount of those nodes actually do have to agree. So this is really Xrp Ledger's method of solving the double spend problem. And this is really why we're all here today. Bitcoin, proposed solving the double spend problem using proof of work. This was a novel way to solve, this double spend problem. The Xrp Ledger, is built on a slightly more kind of scalable in terms of resource constraints around these rules. So this is just a visual of kind of what happens in the process. So first, nodes actually broadcast proposals, and then those get updated based on the trusted proposals of each server. And then once those sets, they keep getting updated. Finally, when a quorum agrees, the actual transaction set is applied. And then a validation is issued, and the whole process starts over again. Now, this actually happens, pretty quickly. It's 3 to 5 seconds. Every transaction set is approved. So you'll see, block times in Bitcoin can take anywhere from 10 minutes and to receive a full 6 confirmations, 60 minutes. So 3 to 5 seconds is a lot faster. The first time I ever sent an Xrp transaction, I thought I did it wrong because it was just so fast. Then once I realized that this was like because of the design of the protocol, I thought it was pretty cool because it felt really like sending an email, which is kind of how you would expect a new settlement network to operate. So like I said, it reaches consensus every 3 to 5 seconds through this process of submission, validation, confirmation. And this happens 24/7, 365. So, we like to say, cryptocurrencies never sleep. And this is really kind of the truth. Nodes are running all over the world. There's about 1,500 or so nodes on the network. A subset of those, roughly about 150, are running in validator mode, which they're actually running and participating in consensus. A subset of that is actually appears on what we call a unique node list. And Ripple publishes a unique node list based on objective criteria of like which servers are running the best, have the highest uptime, have the highest agreement rate, have really good, strong security. operational security around the server. The servers are distributed across different geographic regions, running different systems. And so that list is basically, approved by the network. Anyone can publish their own list. They can choose to trust that list over another list. But this is really kind of the crux of how consensus is achieved. The most important kind of component of consensus is what we call transaction ordering. So you can think of, if the whole double spend problem is, if two transactions are submitted at roughly the same time, which one goes first? And the way that the Xrp ledger does this is through a deterministic process where transactions either conflict or they don't. If they do conflict, then all the nodes in the network will come to agreement that the second one fails. And this is a critical part of the actual ordering. We call these servers validators, but really what they are sequencers. They're sequencing the transactions in order, and they make sure that they run this process to do that. So there are some advantages to running the Xrp Ledger consensus. First of all, you don't have any rotating dictators. So the notion of a node having more basically voting power than another doesn't exist. You don't have any forced stakeholders. If you ever get a chance, David Schwartz gave a great presentation at the Stanford Blockchain Conference last year about why no incentive is a good incentive, where you can make the argument that a miner in a proof of work system is kind of a forced stakeholder in the system. They are providing kind of trust in the system, but they're also kind of forced economically to do that, which you could argue is good, but it also has some drawbacks. The users know the users choose who to trust. So by every user is basically trusting whatever the proposed unique node list is. They can choose to trust another list, and they have that optionality to do that, which we think distributes the trust across the system. It's very fast, like I said, and the most important part of any decentralized blockchain is the past can't be rewritten. So this is a critical component. You want to make sure that once you have transaction settlement finality, that transaction can't be rewritten in history. So just a little bit on Interledger, and then of course, Tyler and Michael are going to go into some more advanced kind of components of the Xrp ledger shortly. So the Interledger is classically an open standard protocol. It's this universal way to clear payments more on the messaging layer. It's scalable to meet global demand. So it can handle really high throughput in a geographically distributed network. Works with any currency, fiat and crypto. We've seen, I subscribe to the belief that I don't think fiat is going away anytime soon. So we have to ensure that the networks that are processing these crypto transactions, the fiat transactions can also benefit from that. So Interledger is really an important element in that. Interledger works a lot like the internet and classically like your TCP/IP, which I'll kind of show here. So you look at the internet architecture. This is pretty classic for anyone, history of the internet, where you have that physical kind of layer with classic. A lot of countries are adopting fiber. You have the network layer, which is your classic like Ethernet, Wi-Fi, Bluetooth. Then you have the internetworking layer, which is the internet protocol. And the internet protocol revolves around what we call packet switching, right? Where you're actually sending packets of information all over the world through something more like a transport protocol. And then finally, you have the application layer, which is what most people kind of understand, HTTP, SMTP. These are the abstractions on top of this TCP/IP stack. So in a similar sense, so this is like the stack for how to send data. The internet it's done pretty well. I think there's upwards of 25% of global GDP is transferred through the internet, on an annual basis, and that's growing. So, in the wave of COVID and everything, e-commerce transactions are increasing. So we only see more and more GDP being processed through the internet. And this is a pretty great way to send data. Interledger actually took a very similar approach. So instead of, at the base layer, you have the ledgers, or these are your classic blockchains and ledgers, Bitcoin, Ethereum, Xrp Ledger, you name it. On top of that, you have a layer 2, which is kind of designed toward scaling, where you have payment channels, state channels, side chains. The Interledger comes in at layer 3. And this is where, it sits on top of all these different technologies. It's completely agnostic. You can run Interledger on Ethereum just as easily as XRP or Bitcoin. There's transport protocols that are being developed. Stream protocol is an interesting one. It's really designed for, streaming payments to go with streaming content. And then finally, you have the application layer, open payments, Pay ID, which Michael's going to talk about next. These are, really the abstraction layers on top of this stack. And, you can understand, like, this is a great way to send value. So similar how, the internet sends, data, the Interledger can send value. So the Interledger, instead of doing packets of information, the Interledger breaks down into packets of value. So there's 3 different packet types. There's your prepare, your fulfill, and your reject. So it's pretty simple. There's 3 different participants. There's the sender, there's a connector, which is really like a router, and then finally the receiver. And in this kind of scheme, you have basically the sender that prepares a packet, the router forwards that packet to the receiver, and the prepare packet has, some information in it, including an amount, when it expires, the execution condition, and the destination. At that point, the receiver can either choose to fulfill or reject the packet. The fulfill packet has some fulfillment data and then other information. The reject packet has basically the code for determining the rejection, what it's triggered by, a message, and then other types of data. So in this sense, the receiver can choose to fulfill it, which is forwarded back, by the router to the sender, and then the payment is completed. So this kind of method, we've seen, the Interledger kind of grow pretty consistently. There's been over 10 billion transactions actually sent across the Interledger, which we think will continue to grow. And one point is, like, the actual transaction size of each transaction is really low, so you can really do small, tiny microtransactions on this. So with that, I am going to pass the baton over to Michael. Michael, I think you want to screen share. You want to take it over?
Hey, everyone. So as Warren mentioned, I am another member of the RippleX team. I run product for our group. And as Warren mentioned, we're really focused on driving open source protocols, among them Xrp Ledger, but other protocols that are complementary, like Interledger, as Warren just mentioned. And actually, Warren, do you mind driving the slides here for just the next few? So one of the areas that we focus on are solving pain points for developers on Xrp Ledger. And in many ways, those are pain points that are shared by developers not only across all of crypto, but also of all payments. And the Pay ID protocol really fundamentally focuses on a general problem of that sort, how you address and fundamentally send money and value to people, whether it's on Xrp Ledger, or if it's on Bitcoin, or it's over a wire transfer. So on the next slide here, Pay ID really is meant to solve the issue of addressing. And if we compare another addressing system that under the hood is somewhat complex, email, we note pretty different experiences. In email, I send an email perhaps to warren@gmail.com, and that might be going to a specific SMTP server over a certain port with certain permissions at a particular IP address, routed over the domain name system. But at the end of the day, from my perspective as a user, that's just an email address. I put it in the to box and it just works. Contrast that with how payments work in crypto. You will have a random string of numbers and letters, typically encoded in something like base 58. It's completely inscrutable, has no relation, fundamentally, no ties to the recipient that you're sending it to. And we actually get a similar experience in something like an ACH payment, where you have or a SEPA payment in the EU, where you'd have, for example, a routing number or some bank code that again is just some string of digits, and then an account number, similarly a string of digits. And I don't know about the rest of you, but something that I feel, and a very common feedback that I hear from the crypto community as a whole, is that it's a nerve-wracking experience. Anytime you want to send something, I'm always double checking, triple checking the address, looking at checksums. There are some fancy ways that you can help ameliorate that process a bit. But at the end of the day, it's pretty much a terrible user experience if we're all being frank and honest with ourselves. So how can we expand on that? How can we take the ideas from email, where we're abstracting away complexity, and apply it to payments broadly? So again, not just Xrp Ledger, not just crypto, but all payments. And so what we came up with is Pay ID, and it works just like email. It's a payment identity that is tied to a particular user and quite unique to them. And it abstracts away the payments complexity here. You don't need to have domain knowledge about the particular payment rail, like what is a SWIFT code, what is a BIC code, what is an account number, what address should I be using here. That gets abstracted away, and you're left with simply a polished, streamlined user experience. So on the next slide here, we see the actual form of Pay ID. So you'll notice here at the top here is user $domain.com. $sign was chosen because it makes it obviously distinct from email and related to payments. It's on pretty much every keyboard around the world as we think about payment systems that do span globally. But it's immediately familiar to anyone who's ever used email. So from that sense, it's much more accessible. We know who user is, we know who domain.com is. And the best part about this is this spans all payment rails. So many applications, for example, whether in traditional finance or in the blockchain space, might have many rails. Your bank might have ACH, SEPA, wire enabled, perhaps a direct bank transfer. A crypto exchange might have tens or hundreds of different cryptocurrency types that are enabled. And you have a different address for each of those. And that also is a pretty bad user experience. Here we can combine all these addresses into a single identifier that spans all of them. So on the next page here, we get a little sense of how this works. And the great thing about Pay ID is we try to make it as dumb as possible, as simple as possible, and as familiar as possible. So there isn't a underlying blockchain running here. It would be equally as familiar to someone who operates a traditional business as someone who has an existing blockchain integration. And it does so by relying on existing technology like domain name system, the HTTP APIs, and simple existing internet networking. So you don't need to tap into any particular blockchain. That's what makes it powerful and extensible and eminently useful. So in something like an email, we go from user@domain.com. That ends up being resolved in some form of email server, and that ends up being processed in a database that ends up in the user's email account. In a similar way, you have a user $domain.com as your Pay ID. We can see from that identifier that that's a Pay ID hosted on domain.com, so leveraging the existing domain name system. And then we use an HTTP API call to that Pay ID server to say, hey, I want to send money to your user who has a username user. And then the underlying network information and all the information that's needed to resolve that payment gets returned over that secure communication channel. So again, anyone who's run any email service, if you have a website as a business, this is something that your tech team is already familiar with. There's no building blocks here that are new. So combining simple technologies in a way to provide a powerful experience. So the next slide here, I'll be pretty brief. I don't want to get too much into technical weeds. But like I said, this is using HTTP endpoints. It translates a Pay ID into a simple endpoint. This can vary depending on the service, and there are ways to have more complex routes. But that's all hidden from the end user. And we can see here some examples of resolutions on the right side. And that could be Xrp, could be Bitcoin. And the type of network that you want to use is ultimately specified in this query. And the cool thing about this is it's using a fully distributed system, one that works to secure trillions of dollars of economics already, the internet itself, HTTP requests, and the domain name system in a way that simplifies a problem that is common across all these networks. So on the next slide here, well, what do we get here from Pay ID? It's a simple and secure communication channel between wallets. These are solved problems. People know how to have secure communication over the internet. And so it's not settlement. This Pay ID doesn't handle the actual settlement layer. That's handled after the address is returned. It's simply communicating and setting up that payment in a way that removes all the complexity for the user. But once you have a channel between two wallets, you can do some really cool stuff. And so there are several extensions on top of this. Pay ID, just to be clear, is a standalone addressing scheme, but you can add some layers on top if you want. So things like enhanced checkout, this can support, I think in the previous slides, we've been mostly focusing on a push payment. I want to send to user at this Pay ID. So give me the information so I can push a payment to them. But things like pull payments and subscription payments, those are the dominant payment methods on the internet today. And those two can be enabled in really cool ways using Pay ID. Verifiable Pay ID, so a common question that comes up, well, if you're relying on existing services like Gmail or similar that you'd have for email, you'd have the equivalent, perhaps a user $bitpay.com, for example, as the Pay ID hosted by a particular service. How can you have a non-custodial layer? How can you introduce the core, many of the fundamental principles that blockchain was founded on, self-sovereignty and self-custody of assets into Pay ID? Well, it turns out there's a pretty straightforward way to do so called Verifiable Pay ID, inspired by WhatsApp and Signal protocols. So maintaining a strong user experience. Things like compliance and travel rule are a very hot topic in the industry today, particularly in the exchange space. Pay ID can help simplify those. And digital identity more broadly. Pay ID you can view as a very primitive digital identity. It's not trying to be a full digital identity that includes PII or information about who you are, but it does give you information about how to contact you and how to pay you. And so this is very much complementary with other digital identity proposals and initiatives that are out there. So on the final slide here, before we take a little bit of a break here, and happy to answer questions in the interim, I'll dive into one of these extensions, the one that I think is potentially the most cool for my personal experience, e-commerce. So as I mentioned before, when you check out on something online, typically that's a pull payment. You put in your credit card number, and perhaps it's even a subscription payment where that credit card is going to be hit multiple times. And PayPal has done a ton of interesting stuff among other fintechs about improving the checkout experience and making it more secure. Ultimately, just exposing your credit card number is amazingly insecure and causes a ton of overhead in the payment system for fraud detection and fraud resolution when it does in fact occur. And so we want to not just expose our number to anyone. And so how can we marry these two concepts? An open queryable address and one that also can enable pull payments in a user-friendly way. Well, it turns out if you actually flip the script, instead of saying, I want to send to Alice, I want to send to Bob rather, at this pay ID, Alice will instead put in her pay ID into a checkout experience. And then much like a PayPal style checkout, but in a fully distributed, decentralized, open way, that checkout experience can then redirect to Alice's wallet, whether that's in a web browser, if it's on a mobile device, or anywhere else. Really, all flows are possible. And you can do some really smart things like querying automatically what currencies are available, the amount to pay, and then you get redirected in an approval process. So just a quick overview on how Pay ID can be used to improve user experience, simplify transactions, and ultimately, I think the end goal in all this is continue to drive greater adoption of this technology and continue to chip away at barriers that might keep average people who don't have sophistication necessarily to understand all parts of all these payment protocols. How can we enable them to use this technology in compelling ways? So that's the idea behind Pay ID. Like I said, something that we sought out to solve a problem in the Xrp Ledger, and that happens to be a problem that's common across all payments. And so it morphed into something that ultimately does work for all payments. And we thought that was necessary.
Hello, welcome back. I think we are ready to proceed to the next part. So, guys, the virtual floor is again yours.
Everyone, Elias, I believe my video is, there we go, perfect. All right, and before we dive into the next section here, there are a few Q&As that I thought would be useful just to answer verbally here. So the first was from Robert. For the user, how does Pay ID differ from PayPal, which is also essentially sending and converting multi-currency payments from email to email? So it's a great question. And I mentioned PayPal, among other systems like email, as some inspiration. I guess there are two differences. One is of scope and one is of openness. First is Pay ID, and this came up in a few other questions. It's simply a payment setup layer. It's almost like a shim for the technical people out there. And it provides an intermediate abstraction. So it's not doing all the end-to-end payment messaging. It's not doing any settlement whatsoever. It simply says, I want to send a payment to this user or from this user, and how do we get started in a way that abstracts all the details from the end user? So that's one, but it's also a good question here of how PayPal might differ from other open systems, and it's really in just that, in openness. And PayPal, even though, as an example, PayPal owns Venmo, but I can't send from my Venmo to PayPal. And even if they do bridge that gap, I can't send from my Venmo or PayPal to Square. It's a closed garden ecosystem, and that's their business model. Obviously, they've been extremely successful in doing so, but our approach is somewhat different in that we really promote and believe in open technologies. I will note, though, that Pay ID could easily be used to bridge those gaps. Let's say a user on PayPal wants to send to a user on Square. Well, I'm almost certainly will have namespace conflicts. So Square has something called cache tags. PayPal has something called paypal.me, where you can get a username in addition to things like email. Say you wanted to send from PayPal to someone on Square. Well, if there are two users called Bob on both networks, how do you know who the right Bob is? Maybe you want to send to the Bob on PayPal. Maybe you want to send to the Bob on Square. Maybe you want to send to the Bob on Alipay. By having Pay ID, you're able to resolve those namespace conflicts using the domain name system. So anyway, hopefully that illustrates the difference in some ways. Sharon asked, what's the consensus and identity verification method and security governance? So very good question here. This will vary a lot depending on the deployment. I gave a little bit of color of this in the chat, but there are basically two types of scenarios. One would be some custodial wallet, and this would span to traditional finance. You're already trusting PayPal as an example, or any other, your bank, whatever digital wallet you might be using to safely custody your funds. It's not like you own your funds, your cash on your bed, and they're just providing you like a portal into it, like a non-custodial wallet will. And so ultimately, it's up to that service provider to provide the security, just like they currently provide the security for the funds themselves and the online portal into it. Same thing with identity verification. For what we call Verifiable Pay Id, I touched on this very briefly, and the details get a little more complex underneath the hood. It's kind of standard cryptography involved here, but I don't want to get too deep into detail. Basically, you can have a non-custodial model together with Pay ID. I mentioned the inspiration here was from Signal and WeChat. So both those are end-to-end secure encryption with identity keys that live on your device. It's sort of hidden from the end user, but that's how it functions under the hood. And you can verify that with your friends and see we can take the same concept, apply it to Pay ID. And the result is each of the Pay ID associations is signed and secure. And anytime, let's say someone maliciously tried to swap it out, well, anyone who was trying to pay you would notice that the key would not match up, and so would be able to identify the exploit before the payment was sent. So the security there would boil down to your standard out of the box properties that would go along with a non-custodial wallet. I will apologies for mispronouncing the name in advance. Basharula asked, why do we need Pay ID? When can we integrate Pay ID with our email address? So I think there are a few points here. It's actually a really good question. We're sort of considering this as a serious option. Why not just use the email format? There are two main reasons, both related to security and one related to also related to user experience. Start with the second one here, which is everyone pretty much has an email. Not every email will start running a Pay ID initially. And so from a user experience perspective, that could be very frustrating. You don't know if something's for payments, if it's for email, if those things are separate. And so you'd end up with a lot of failures. So we wanted something that would preserve the use of Pay ID and the usability, but would eliminate those failures. Now, it's important to note you could map an email one-to-one to a Pay ID. So let's say you have a Gmail and Google somehow got into the business of sending funds on whatever rail. Your Gmail with an @ sign could map directly to a Pay ID with a $sign. And so you get a one-for-one mapping there. So it'd be pretty easy to smooth over if that's the direction you wanted. The second main reason, though, security. If you have coupled messaging and the payment resolution systems, that just opens the door for tons of phishing exploits. I mean, email is already notorious for this. Probably the one weakness. Pay ID is not meant to be a way to contact the end user. It's meant to contact and get limited information back. How do you complete this payment? It's not a way for you to send, hey, there's this giveaway. If you send $10 to this address, then we'll send you back $100. Your classic phishing attacks and other exploits that rely on communication between the user. We wanted to make those strictly segregated and significantly reduce that attack surface. All right, so I know I went a little bit over on the Pay Id section. With that, I will turn it over here to Tyler Storm. Tyler, why don't you give a quick intro about yourself, and we'll be discussing really cool area, fungible tokens on the Xrp Ledger and how they can fit into a number of different use cases.
Yeah, so just to add to the previous one though, if you guys have a lot of more questions or you want to like play with Pay Id, you guys should definitely check out payid.org and check. And if you want to like play with it, use the sandbox. So it's payid.org/sandbox. It's a great way to kind of visually see how it works and like get familiar with it, as well as just you can check the documentation. So yeah, so like Michael was saying, I'm Tyler Storm. I'm a senior software engineer here at Ripple. Mainly I work on ledger tools and applications that help highlight the functionality of the ledger and kind of make it easy to use for end users, developers, and just kind of overall bring more people into the community through the tools and services that we build. I'm going to share my screen here and go back to the presentation. All right. So as you can see, we're now going to talk about issued currencies. So what is an issued currency? And the issued currencies on the Xrp Ledger that we will be talking about are fungible tokens. So fungible tokens are like the US dollar or like any currency that you're familiar with. They're interchangeable. Any token can be exchanged with any other token of the same type, and it will have the same value. So like, you know, if I give you $20 and you hand me another $20 bill back, they're both worth $20. They're also divisible, so we can divide these down into smaller units, such as like cents or like a quarter. And then some examples that I have listed here is TrueUSD, Tether, USDC, and Paxos. These are all examples of stable coins that are fungible tokens. So to talk a little bit about the industry landscape that currently exists within the token issuance space and the issued currency space, almost all issued currencies that exist in the market today are some variant of a smart contract ERC20. So what this really means is that whenever you want to issue this currency, effectively you're issuing a series of code on the ledger that will then interact with other individuals that are using the ledger, and they can then create tokens that way. So the contracts are built on top of this standard reference implementation for ERC20. This is like the standard way of doing it. Now, of course, there's other blockchain platforms that have their own variant of smart contracts. And what we're also seeing in the space as well is that there's newcomers to the space that are adding additional ways to have more of a hard-coded functionality of doing tokenization on the blockchain. So things like Cosmos, potentially Polkadot and stuff like that are having other different ways of doing that. But currently the standard out there these days is the smart contract methodology. Now, there are a couple issues with the smart contract system, mainly that if you make any mistake in building out the smart contract, effectively you can ruin the currency or make it exploitable. If you stick to like the reference implementation, you're fine. But what ends up happening is a lot of these token providers want to add some sort of additional functionality to their tokens. So what they usually do is they come in and they modify the smart contracts to have this additional functionality, and they sometimes end up introducing some sort of bug that can lead to loss of funds or something catastrophic like that. Luckily, though, the main providers in the space have been pretty secure, and it's not had too many issues. So why should you consider issuing tokens on the Xrp Ledger? So Xrp is a little bit different from like the smart contracts and the ERC20 style of issuing currencies. We actually have built into the ledger the ability to issue currencies. So what this does is it actually removes the need for you to write your own code to issue your currencies. And you can actually just use the built-in functionality. It's almost like calling a bunch of APIs, and you can issue these currencies. So this makes it extremely simple for anyone to issue currencies, and this solves the primary use case of most tokens. There are some cases where you would want extended capabilities, and we do have functionality that can allow you to leverage that. But for the most part, this covers 90% of all the needs of the tokens that are currently out there. So when you have this, this is also going to remove that issue of introducing bugs, because of the fact that this code has been in existence since 2013 and in production use. XRP has been leveraging this technology for a long time, and it's battle tested and it works. Another huge advantage is Xrp Ledger has very fast settlement on 4 seconds to get things settled. Very high throughput, up to 1,500 transactions per second that we've tested. We have extremely low fees, which is a huge advantage right now, considering that the average transaction cost in Ethereum is pushing like $1.50 sometimes. We also have a built-in decentralized exchange on the ledger that will allow you to kind of set values between different issued currencies. So if you have like an issued US dollar and you have an issued euro, effectively like there could be a decentralized exchange system in place that could actually facilitate the exchange of these wrapped US dollars and these wrapped euros. And like I said, this has been battle tested. It's been out there since 2013. So it's definitely something that's been stable and in use. So what does it look like to actually issue a currency on the Xrp Ledger? So what you must first do is, because of the fact that this system is an opt-in system, which means that anybody who wants to transact using the currency, such as the like a true USD type currency or like some wrapped US dollar, what you must first do is you have to open a trust line, and what this does is you're opting in to receive that currency. So effectively, you're telling the issuer, hey, I'm willing to have this wrapped USD on my account, and I'm willing to have up to this amount at a time. So once you create the trust line, then the issuer can then mint the currency and send them to your account. And then once they're on your account, you're now free to transfer and exchange those. So you can send those to Bob or whoever, or you can even trade them on the decentralized exchange. And then at the end of the day, if you want to convert these back to, like, say, a US dollar, you will then redeem them with the issuer by sending them back to the issuer, and the issuer will credit you back in the real world with the fiat money that you are owed. So now we're going to dive into a quick demo. Let me stop sharing and I'll adjust here. All right, so this is a demo that we built for a potential partner that was looking to do stablecoin issuance on the Xrp Ledger, along with the ability to have interest rates associated to it. Especially due to the pandemic, we've seen countries in the European Union that have changed the euro's interest rate to a negative interest rate to promote spending. So effectively what happens is, as you hold the euro, you're actually losing euros for holding them. So this promotes spending and economic growth. And then in contrast to that, we also have positive interest rates, such as like when the US dollars, has a higher interest rate, you can gain money back from the Federal Reserve, interest on your money. So we're going to do a quick little demo here. So if we refresh the page, we're going to fund each of these accounts with some XRP on the testnet. You need XRP in order to pay the fees to issue the currencies. So on my Genesis account here, we can issue a euro. So we'll do that. And then over here on the right, I should mention, we have the ledger results. So this message that you see here where it says submitted set default Ripple. This is the first message that is being sent to the ledger, and then this is the success message that comes back from the ledger once confirmed. So we can see that here. So now, as we can see, all the accounts have funded, the currency has been created. Now we have to open trust lines. So now we're going to say Alice is going to make a trust line with the Genesis account to say, I am willing to hold euros if you want to send them to me. So I'll opt in under Alice. So we submit that message. And now it's confirmed on the ledger. So we'll issue 100 euros to Alice. So what this represents in the real world, what would happen is Alice would go to the Genesis Gateway's website, and she would send them 100 euros worth of a wire transfer, SCPA transfer, and then they would credit Alice's account on Ledger with 100 euros. So as you can see now, Alice has 100 euros on the Ledger, and then this value here is an adjusted value. So what we have is the ability to like add negative and positive interest rates, which what this will do is the amount of money that she has on Ledger will not change, but the amount of money that we display, the adjusted value, will change based off of the interest rate. So in this example, let's say that there's a daily interest rate of 1% that occurs. So we submit that. And what this is actually doing is because, like I was explaining earlier, XRP contract doesn't have like the contract system that ERC20 has. So what this system actually does is leverage the data fields that we have on the XRP Ledger to add a memo to the message, the transaction. And what this transaction I'm submitting has a memo property that says adjust the interest rate of the currency by this amount. And so that goes live and goes out there. And then anyone who is anyone who's connected to the Ledger can see this and then automatically know what their adjustment factor is. So currently the Euro adjustment factor on this account is 0.99. So as we can see here, Alice has 100 euros on Ledger, but we multiply by the adjustment rate. So she actually has 99 euros adjusted because of the negative interest rate. So now if I were to open Bob's trust line to the Genesis account, we can then submit this. And now when Alice sends to Bob, so let's say that Alice wants to send 9 euros to Bob. This is going to be sending your adjusted euros because Alice, as an end user of this platform, doesn't really know that she's transacting with adjusted euros. She just knows she's sending euros. So what happens here is she sent 9 euros to Bob. There's some very specific rounding here. Obviously, this isn't like super polished. If this was like a production level thing, I would make this a little bit cleaner on the rounding and get this to be a little bit more accurate. But as you can see now, she sent 9. So on Ledger, she has 90.9 euros, but because of the adjustment rate, she still has 90. And then Bob received 9.09 euros on Ledger, which results in 9 euros adjusted. So they're always transacting in this adjusted euro value. And then due to this, I can also say, well, let's say that, the euros now has a positive interest rate. So, bear with me, I'm putting a negative in here, but like the idea here is that this is actually doing a positive adjustment rate, a positive interest rate. So now like the value is 0.9999. So as you can see, pretty much the value they have on Ledger is exactly the same as their adjusted value. And then if I were to issue Bob 100 euros, Bob would then go up to 109 euros on Ledger and pretty much 109 euros adjusted. Also, if I say, let's say I continue this interest rate, so now they get 10% more money. As you can see here, now Bob has 120 adjusted and 109 on Ledger, and you can see the current adjustment rate here. So this is kind of a way that we can modify just this core functionality of having on Ledger data in a decentralized way, but also be able to provide certain data and parameters around it to kind of give it more smart contract-like functionality, while still keeping the high throughput, the high transaction speed that XRP Ledger has. So this is just like a very clean and simple way to kind of create these are like the primary use cases for tokens at this time. There is a lot of interest, being in the DeFi space, and tokens are really starting to evolve. But the primary use case that we really have seen is around stablecoin issuance and these sort of issued currencies. So XRP Ledger does a fantastic job at doing this and makes it's pretty much a lot easier to do this compared to like what it would be to issue a smart contract on like say Ethereum or like Tron or the other smart contract systems where you can issue tokens. one other thing is like the amount of code that was actually needed to do this is very little. So if I pull up my other screen here, hold on. So the code that's actually needed to do this is fairly little. It's approximately just 250 lines to handle the like funding from the faucet, setting the daily interest rate, sending tokens, and issuing tokens, and opening a trust line and enabling the rippling functionality that allows you to transfer money between like Alice and Bob. So the amount of the code here for the actual like ledger specific code, and this is all TypeScript, which is like JavaScript. It's very, very minimal to do. And this is done using the RippleLib API. So it's a very easy package to use that makes this very simple. Of course, the UI for this is a little bit more extensive because it's a little bit of UI to make things auto update. But overall, this entire demo that you saw was only 1,000 lines of code in total. So it's very simple to build these sort of stable coins and applications on XRPL. So let's see here. Now I'm going to pass it over to Michael, and he's going to talk a little bit more about smart transactors, unless like we want to answer any questions here.
Yeah, so thanks so much, Tyler. And I think of just re-emphasize of the code that you showed, that was the full end-to-end application, the actual, including the front end and the transaction initiations, and all the GUI elements that you did, plus the actual issuance of the token. So the issuance of the token was only really a subset of that. Two questions came up. Anna asked, is the code open source? I believe this demo is not yet open source, but will be shortly. I think we'll be publishing a blog, something similar about it that just gives a little walkthrough. We'll probably want to do a little bit of cleanup here. But beyond that, there's lots of demos that are open sourced along some of the lines. Xrpl.org or RippleX.io are the best starting points there, and you can probably get pretty quickly into a GitHub repo. And Patrick asks, I wonder if this could be nice, but wonder if this could be used in a regulated financial world. It's a good point. There was an earlier question about security tokens on Xrp Ledger. So all those are totally possible. The fact that you're using a blockchain doesn't mean that you are exempt from relevant laws and regulations. So it would depend on the circumstance. There's increasingly more guidance around things like stablecoins, which is what this demo focused on. Things like security tokens also are advancing. A number of projects out there doing that as well. Ripple, who we represent, isn't involved directly in any of the above, but certainly those activities are possible. You would just have to take into account the regulatory framework in place. All right, so with that, thank you, Tyler.
Thank you.
And let me share my own screen now. Oops, there we go. All right, and Tyler, are you able to see this at decent resolution?
Yeah, it looks good to me.
Excellent. All right, so what Tyler just showed is actually a great lead in here, and one example of what we call smart transactors. And Xrp Ledger obviously can do payments. That's really its bread and butter. But beyond that, it can do a lot more. We just saw how fungible tokens, which we call issued currencies, can be used in some interesting ways, and there's some good flexibility there. But there's a whole class of things that we call smart transactors that are higher order transaction logic. And there's an important distinction here between smart contracts that you might find in something like Ethereum, as Tyler pointed out, and smart transactors. And to summarize, there isn't really a right or wrong answer here. We view our Xrp Ledger as very much complementary to things like Ethereum or Bitcoin or really any other protocol out there. We try to specialize in the areas that we, or Xrp Ledger, I should say, which is, it's obviously a large decentralized initiative, really specializes in areas of high performance and tries to preserve those properties. Whereas something like smart contracts has a very different purpose. So a smart contract at the base network is not included in Xrp Ledger. And a smart contract I would define as something that enables arbitrary code to be executed in some virtual machine environment. And that gets synced across, obviously, the entire network. And that has, like I said, both pros and cons. The pro is that you can get to do anything with that. The con is obviously there's additional overhead entailed, and that can be quite significant and erode performance. And so instead, the direction that Xrp Ledger has taken thus far has been smart transactors. And these are, just like we saw with the issued currencies, higher order transaction execution logic that's built directly in the protocol itself. So instead of writing, in the previous example here, a full ERC20 specification that conforms to the ERC20 standard that needs to get audited, and that could probably run you 500K or more in a production setting, depending on your risk team and business team. Instead, the transactors that are built into XRPL are much easier to set up, and they're optimized individually, so they have much higher performance, and as a whole don't degrade the overall system performance. And so that's the trade-off that Xrp Ledger has made. Like I said, not necessarily a right or wrong answer here, just different approaches and ultimately different use cases. So some simple examples here. The simplest one is payments. A payment itself, you can think of separating out a state change machine, which is basically what a blockchain or ledger is, a decentralized ledger, and the actual state change themselves. And the simplest state change that can really occur in this type of system is a payment where you just update one account, you credit and you debit two accounts. Another simple example, like I said, is issued currencies. And there's some more advanced functionality built on top of those that Tyler hasn't shown. Things like rippling, which was what inspired the original name of the company. And the idea there is somewhat similar to a layer 2 solution like an Interledger or a Lightning Network. But you can settle payments by netting out lines of credit between users. I won't get too much into detail here, but the trust lines that Tyler mentioned can be viewed as a credit arrangement, and you could settle credit amongst the hop along the network, and so more efficiently settle a payment. And then things like interest, Tyler obviously showed one example. There's some other interest types that are built in as well. So what are some other transactors that we haven't seen yet? Well, the first one here is Decentralized Exchange. The DeFi space has really exploded over the past several months here, largely focused around things like Decentralized Exchange, as well as a few other use cases, but really dominated by lending and decentralized exchanges. And the Xrp Ledger for many years has contained a fully functional order book exchange. And this is a place, a venue where users can trade fungible tokens like the issued currencies for XRP or each other. And so really any token that's issued on Xrp Ledger can be traded through this exchange. It consolidates all liquidity into a single spot in a fully decentralized manner. This has a number of useful features. So as I mentioned, this is an order book exchange. So any really traditional trading venue operates on a similar system where you can submit various types of orders, market orders, limit orders, stop orders, et cetera. You have full control over the book, and it's a relatively sophisticated order set. And then there are other cool features, things like auto bridging. So let's say that there's two stable coins on the network, and both have deep liquidity against XRP, but they don't happen to have deep liquidity against one another because they're somewhat lesser traded currencies overall. You could think of non-G10 currencies as an example here. Well, auto bridging allows you to automatically connect those two order books. So rather than swapping on the very low liquidity stablecoin A versus stablecoin B book, which could entail a lot of slippage. If the price is better, including slippage, then auto bridging will facilitate a trade from issued currency A to XRP, and then from XRP to issued currency B. So really cool features that are built in here, a number that I won't go into in this presentation. So smart transactor number 2 are payment channels, and payment channels boil down, there's some complexity here that I'm simplifying, but basically a way to send asynchronous payments on Xrp Ledger. And these can be divided into very small increments and settled later. So this is not something that's unique to Xrp Ledger, but the Xrp Ledger has a number of wrinkles. It also obviously composes with a network that's already optimized for payments. So in Xrp Ledger, the payment channels are bi-directional, and I'll call it the magic of cryptography and do a little hand waving here. But the basic idea is you can set up an initial transaction on Ledger with certain cryptographic conditions embedded, things like a time lock and a hash lock in particular. And what you end up doing thereafter is exchanging messages off Ledger. And these messages can be thought of as claims. And since these are just exchange off Ledger, i.e. over the internet, there's not really any cost, and it's fully real time. It's just the amount of time it takes to send a message from one computer to another and the cost that it requires. So effectively zero for both. And the important thing is at any time, either user can unilaterally settle on the ledger at no risk of loss of funds. So if Tyler and I have a payment channel set up, it's initially funded with $10, $5 on either side. I pay Tyler $1 for some good that he's provided me. Now the payment channel balance would be $4 on my side, $6 on his side. If I wanted to go and run off with the money, turns out I can't do that. Tyler is guaranteed to receive his $6, even though that transaction hasn't yet been recorded on the ledger. And so really interesting building block here for more efficient, higher order applications, and a lot of opportunity for composing. Really, this is the core building block of things like layer 2 solutions in many cases. All right, Smart Transactor 3, we'll go back to something that's perhaps a little more familiar to the audience overall here, escrow. Escrow is obviously something that's extremely common in traditional financial transactions. And the core concepts hold here, although they're somewhat generalized. And the basic idea is you have conditional payments on the ledger. I might pay Tyler conditional on a third party approving, or I may pay Tyler conditional on a certain time elapsing before the funds are released. And these conditions can get relatively sophisticated here. And I think this is the idea that a lot of people often have in mind when they think about smart contracts and programmable money. This really gets at the heart of it. Having not just a dumb transaction that has a binary state, either it's been sent or it hasn't been sent, but rather having more complex states possible with a broader set of branches on the tree, so to speak. And so, like I said, time locks, crypto conditioned generally is what they're called on the technical side. And these can be quite expansive. Now, let's say the escrow doesn't go as planned, someone gets hit by a bus, whatever, they can be set to expire. Same thing with a lot of these ledger objects. There's good recovery conditions in place while keeping really strong security. Smart Transactor 4, again, a familiar concept, checks, using the American spelling. So checks, as we think about them, they're a promise to pay, but they don't necessarily say anything about the current balance of the account. So it's a similar idea. It's like a unsecured payment promise here. And that promise can be cashed at any point in time by the recipient, and that may or may not fail. And this is very much intentionally structured for use cases where that sort of behavior is the goal. And so if you wanted to have something that's guaranteed to be pre-funded, use something like an escrow. something that you want or prefer to be unfunded that both parties agree to, you can use a check. All right, and so that's really just a preview here. There are many more, and like I said, it's really a design preference here and optimization. In the case of Xrp Ledger, the choice from the protocol perspective was to have the smart transactors that you end up with many of them. So it's more specific implementation, but you're able to optimize each of them and tailor them to specific use cases. And the benefit there is you have higher performance and you make a substantially easier user experience. The flip side would be a smart contract system. Again, a very different use case, one that wants to have arbitrary logic, but at the price usually of the upfront cost to actually implement them, as well as the complexity and performance of the system. So if you want to learn more, definitely visit and check out xrpl.org/concepts. And really what I wanted to show here is that there are a lot of building blocks beyond just sending a payment that can be composed together into more and more complex and interesting applications and use cases. All right. Tyler, any questions come up about that section?
Yeah, I think there was one question was from Nadia was, could smart transactor, could have it been used to prevent the Crediran downfall with the investors losing out? Are you familiar with that? I'm not personally myself.
Let me,
I'm not sure exactly if I'm pronouncing that right.
Yeah, I can't see the specific writing. We might have to get back to you after this here and make sure that we are talking about the right things. I don't want to give an answer that is inaccurate. All right, I think we'll have some time later to touch on some of these points. All right, and so with a few minutes here before we open things up and get back to some of the questions that I know have been piling up, I did want to get a little bit more technical here for just a few slides and discuss some of the tools, services, and programs that are available on the Xrp Ledger. So RippleX, where Tyler, Warren, and myself all work, it's division of Ripple that's, as we mentioned, devoted to open source technology. We generally we're not trying to make any revenue directly here. We are just looking to promote adoption and usage and ultimately utility of the open source protocols like Xrp Ledger that we support. And so a number of things that are available if you're interested in checking out more. I'll start with the second one here. Actually, it's an SDK, software development kit. Currently is mainly available in server-side JavaScript. But that covers a lot of ground these days, and will be expanded in the future to more languages. The RippleX wallet is like a staging ground, provides a GUI interface into the testnet, so very useful for getting some funds to play around with, start testing your application and building your application, debugging your application. That includes both for Xrp Ledger and ILP. The Xrp API, RippleLib, Xrp CLI, these are all just different ways to access the libraries effectively, or APIs, into the ledger. So depending on the type of developer that you or your team prefers, we would have a standard REST API in the form of Xrp API. RippleLib is a sort of power user version of the SDK that is focused on JavaScript, and then the command line interface as well for applications where that type of interface is appropriate. Some other tools here. More generally, there's a distinction between Xrp Ledger and Ripple. Ripple is just one of many contributors to the ledger. And so there are a number of tools that are operated outside of Ripple. So RPC, WebSocket, some data APIs. These are all, again, depending on the type of developer that you have or the type of application would fit this specific use case. Some governance tools like the ledger TOML file, domain verification, and then again, some faucets to facilitate testing and development of your applications in a setting where if something goes wrong, then there's any actual value that's lost. So beyond actual tools, and I'll just note before I move on, those tools are really just a preview. We're very much actively in development of additional language bindings, additional tools, and also services. And so what type of services are there? There are things like test networks, the DevNet testnet for both Xrp Ledger and ILP. Those again are a sandbox where if something goes wrong, you can test out your application and no value is lost. A Ledger Explorer, as Warren described, that's a search engine or data visualization of what is actually occurring within the ledger. And then a data API gives you a more robust view of that in a programmatic way. And finally here, what type of programs that we run. I'll give a quick plug: content, events, support, capital, really across the board, trying to anyone who's interested in using Xrp Ledger or any of the supporting protocols to build and deliver new and interesting user experiences. We are happy to help in a variety of ways. And we definitely encourage you to visit, learn more. If any of these things seems like it could be a fit or inspired any ideas, RippleX, the Xrp Ledger doc site, and then also shout out here the Xrp Ledger Foundation. They're the nonprofit that really oversees the holistic development of the Xrp Ledger itself. So more resources available in all of these areas. All right, so with that, I stop my share here and let us take a look at some of these questions. All right, so an interesting one. What role will Flare be playing in Pay Id and Xrp Ledger going forward? So for those who are not aware, I guess in the context of the conversation around smart transactors, I made the distinction between a smart transactor system and a smart contract system. Flare is a smart contract system that is designed to be particularly closely integrated into the Xrp Ledger. This is an initiative that's unrelated to Ripple, the company, but obviously very much building on the Xrp Ledger itself. And so, I think we find that use case super interesting. Like I said, there's no right answer in terms of how a system is designed. There's use cases where you want smart contracts. There's use cases where a smart transactor is going to be more performant and more user-friendly. And so having the ability that Flare provides, as well as other projects and initiatives in the ecosystem to have full smart contract capability, that just opens up a number of other use cases that are not possible or not currently covered, is probably the more accurate, under the current set of smart transactors. Because ultimately it's not, it's ultimately different use cases and different coverage that they can play. So if that helps there. All right. All right, Sharon asks, how do smart transactors aid in settlements? Compare and contrast, please, transactors versus contracts employed in the settlement process, payment system, trading system users. Okay, so I'll get a little bit more technical here because I think this is needed to actually fully answer this question. And the basic way a smart contract system works is you'll have a certain code that then gets compiled onto a virtual machine, and then all the actual nodes on the network are executing on that compiled virtual machine code. And so typically they're Turing complete, which means that any application that you could write code for on a normal computer, you can write code, you can programmatically deploy in a smart contract, which is then executed in that virtual machine environment. That virtual machine environment would include settlement. So pretty much everything that a smart transactor can do, you could also do in a smart contract, including settlement itself. The contrast here in a smart transactor also can include settlement, but it's built in natively to the protocol. And so in the case of, let's say, an escrow account, and let's do a simple one, you need a signature from a third-party escrow agent to release the funds. So a classic escrow account. That logic is actually written into the protocol itself. And so the just execution, understanding of the nodes of what the right state is determined rather than running virtual machine code, just following the logic that's built into Ledger. And so in both cases, you would end up with settlement. In fact, you could create an escrow system using a smart contract. That would be one of the simpler smart contracts you could probably write. And so I view them as somewhat orthogonal, the question of settlement and smart transactor versus smart contract. And similar to payment system and trading system users, I would say these are different dimensions along of the protocol. So taking the payment system, we just discussed an escrow example. A trading system would be a decentralized exchange. So let's take Uniswap as an example. On Ethereum is the largest application by a significant margin. They're an automated market maker, so it would be a trading system. The code to execute a trade there is basically processed through the smart contract on the virtual machine, and then settlement occurs depending on the output of the state coming out of that virtual machine execution. Whereas on the Xrp Ledger Decentralized Exchange, it's a little more direct, but settlement still occurs. So hopefully that, that clarifies things a bit there. All right, there was a follow-up here regarding the decentralized exchange smart transactor use case. How would this compare to a DEX such as Uniswap, but AMM? Would the smart transactor DEX be non-custodial? Yeah, it's a really good question here. So AMMs are super interesting. They're obviously the new kids on the block here. All traditional exchanges, there might be one or two exceptions out there, but they are order book exchanges. And you know, that's been historically the case because that gives you a lot more flexibility. If you're like a professional market maker, you want to have granular control over your orders, your capital, and the execution that occurs. You want to be able to get in the market and out of the market rapidly. And automated market maker, and so the decentralized exchange smart transactor on Xrp Ledger is order book exchange as well. So you have the exact same properties there. It's more of a power user style system, although I think everyone here is probably familiar with regular limit orders and market orders that might occur on an exchange. So contrasting there the AMM style, basically the idea, as the name would imply, AMM is an automated market maker. And so Uniswap in particular, as Nathaniel points out, uses a constant product formula. Without getting into the nitty-gritty details there, what that means is the price is and orders, effectively the market book depth is determined completely algorithmically. There's no manual intervention, no one's submitting orders. It's simply, and then there's some nice properties there. I mean, number one, if you're just a regular user and you don't want to be connected to the market all the time, but you still want to provide liquidity, then you just deposit it, set it and forget it. You just deposit it in and it works. It's also guaranteed to provide a price at regardless of how many trades have occurred. So some nice properties there. The downside is it's less capital efficient. It's certainly less granular control. You have no control as a liquidity provider. There's just one price and that's that. Also the trading costs tend to be substantially higher because slippage to provide those guarantees, this market can this market maker can make a price regardless of how many trades have occurred in either direction. You need to have certain properties. That's the constant product formula specifically. So those are the chief differences. Again, it's neither one is better or worse. It just depends on the use case here. And the DEX on Xrp Ledger has more power use case in mind. That's not to say that an AMM couldn't be developed and added to the Xrp Ledger protocol itself. It would take the form of a smart contract transactor. That would be a new object on the ledger rather than a new smart contract. But that certainly could occur. And like I said before, it's an open protocol and anyone's welcome to contribute to it. And then the last question there, would this smart transactor DEX be non-custodial? Yes, it is fully non-custodial. All the transactors are non-custodial in the sense that anyone who has the key that controls the transactor, depending on the setup, for example, in the DEX, I would have a key that corresponds to the orders that I submitted. If I want to retract those orders or change them, then the key that I custody can be used to do that. So also fully non-custodial. Okay, so R. Flenner has asked, what's the point of using a DEX on the Xrp Ledger when transactions are basically identifiable at least, I believe, when AML is integrated. So I think there are two concepts here to separate out. The first is, well, I'll start with the second point here. When AML is integrated, there isn't any protocol level concept of AML. It's just the same as a Bitcoin or Ethereum or any other fully decentralized open network out there. Participants in the Xrp Ledger, like a Coinbase, for example, allows people to trade XRP. They can conduct AML on top of it, but that information would be stored in Xrp Ledger. So I would guess the point about identifiability, I think is possibly less relevant there. But I will say in any network, including Bitcoin, it's a pseudonymous network. There are a lot of firms out there that try to link transactions to identities, and that is certainly a possibility in any open network. It's by definition, the data is open and out there to see. And so the question here, why would you use a DEX in that sort of scenario, is an interesting one. And I would argue there are two different considerations here. A DEX fundamentally is a way to swap assets for one another. And so depending on your particular use case, you may want to know who the counterparty is, in which case you might operate an AML layer on top of Xrp Ledger and only allow registered participants on that layer to trade with you. That's possible. You could also be the exact opposite extreme and prefer something that's more private. And there's certainly mechanisms to in best practices in any network, Bitcoin, Xrp Ledger, Ethereum, etc., to preserve privacy as much as possible. But I would argue that the desire to trade assets for one another and the desire for privacy are orthogonal considerations, and there are multiple combinations possible. All right, so I do not want to run over here, and we are coming up on time. So I'll first thank Tyler here for doing that demo. Thanks everyone here for active participation. Really enjoyed a lot of these questions here, and apologies if I wasn't able to get to yours. If you are interested in learning more and building on this workshop, please do go to xrpl.org or ripplex.io. And there's plenty of information there to guide you along the way and help get started. So thanks so much, everyone.
So thank you once again. So overall, this has been an amazing event. Once again, I would like to thank our distinguished speakers. Also, a big thank you to you all for your participation. Before closing the event, there is a short list of announcements. First of all, your feedback is very important to us, so we much appreciate your input to a survey which will be circulated shortly after the event. In addition, all attendees will receive a blockchain verifiable certificate of attendance. And last but certainly not least, the second DLS event is planned to take place on the 15th of December, and the topic is the VeChain toolchain with regards to the digital transformation of the healthcare industry. Please visit decentralized.com for more information and registration. Once again, thank you very much, and we are looking forward to seeing you in our forthcoming events. Thank you. Bye-bye.